Okay, this lesson is on solving linear equations in one variable. A linear equation in one variable can be written in this form. It's a times x plus b equals c. A is non-zero. So we're just dealing with equations that can be written that way for now. I should point out, though, right here, the difference between an expression and an equation. An expression would be something like 3x plus 2x minus 1. Notice that there's no equal sign. That means that we're dealing with an algebraic expression. I can simplify this one, write it as 5x minus 1, but I'm not really solving it. I'm just simplifying. So I've simplified the expression here. Now, something like x plus 3 equals 5, notice there's an equal sign, has an equal sign in it. And that means we're dealing with an equation, and we can solve equations. We would subtract 3 from both sides and get x equals 2. So I have solved this equation. Okay, so in short, an equation has an equal sign in it. An expression here, like this one, does not have an equal sign. This one does. When you do solve an equation, I believe that the book will probably ask for you to put the solution in a solution set, and that just means you use these little fancy little brackets here and put your answer in them like that. So this is the solution set. Some equations, which we'll solve later on, have more than one answer, and so we would be putting more than one number in the solution set. Okay, let's solve this linear equation. 3x minus 1 equals 5. This is something that you would have done in a beginning algebra class, so some of these are still reviews for you. First step to solve this for x would be to add 1 to both sides. I put the 1's underneath like that. So this gives me 3x. These 1's here are gone. And we get 3x equals 6. Okay, the next step then is to get rid of the 3, which is multiplied to the x. So I'm going to have to divide it away. I'm going to divide both sides of the equation by 3, like this. Now 3 over 3 is really a 1. 1x. We usually don't write that 1, though. 6 over 3 over here is 2. So x equals 2 is our solution. And I'm out of room here, but the solution in solution set form would be right there like that. 2 is our solution. Now, you really should check your results or your solutions, though for time I'm not going to check every single one here in the lessons, but the way we would do that is we'd take the original equation, 3x minus 1 equals 5, plug your answer in for x, like that, and let's see if it gives me a true equation. 3 times 2 is 6 minus 1. Yep, that's 5 equals 5, and so that checks. We've solved the equation correctly. So it is always a good idea to check your solutions. Now let's look at this example. There's 2 ways that you could go ahead and solve this equation for x. I'll show you both ways. You could first subtract 3 from both sides of the equation. Negative 1/2 x equals 5. Now to get rid of the negative 1/2 x, to get rid of the negative 1/2, you could multiply both sides by the reciprocal of negative 1/2. Reciprocal, which the reciprocal of negative 1/2 would be a negative 2. Multiply both sides by the reciprocal there. Because a number times its reciprocal is just a 1. Right here, that negative 2 times that negative 1/2 is a 1x now. So this gives me 1x equals negative 10. So x is negative 10. And there's our solution. negative 10. Now another option is to do this. Some people like to eliminate all the fractions right away. So what they would do is they'd multiply everything, both sides of the equation, by 2 first, like this. I'm going to multiply this whole equation by 2, or this side by 2 and this side by 2. Now I'm going to distribute the 2 there, and that 2 times that negative 1/2 x will be a negative 1x. This 2 times this 3 is 6, and over here I've got 16 now. And I've eliminated all the fractions by doing this. I can then subtract 6 from both sides, like that. And then finally I can divide both sides by negative 1 and get x equals negative 10, once again, as my solution. Okay, so it's really up to you which method you prefer. It doesn't really matter. It's going to get you the same answer in the end. We'll see more of these where we eliminate the fraction a little later. All right, here's our next problem. 4x minus 2x minus 5 equals 4 plus 6x plus 3. Okay. I have like terms to combine first here. So I'm going to combine the 4x and the 2 minus 2x there to give me 2x. Also, over on this side, I got this 4 plus this 3, which I can add together, which gives me 7. So this is a 6x here plus a 7. Now I've got x's on both sides of the equation, so what I'm going to do is I'm going to move everything with x's in them to one side, and what that really amounts to is I'm going to subtract 6x from both sides of the equation now. Minus 6x, like that. 2x minus 6x is negative 4x. Minus 5 equals 7. Now it looks like the other ones that we've been solving. So now I'm going to add 5 to both sides, like that, and get negative 4x equals 12. And then we're going to now finally divide both sides by negative 4. And we will get our solution. X equals 12 divided by negative 4 is a negative 3. And so there's our solution, negative 3. Let's, now let me change the screen here. Let's try another one. Okay. Negative 2 plus 3 times x plus 4 equals 8x. Now, to solve this equation for x, first thing I'm going to have to do is get rid of those parentheses by distributing that 3 in there like that. Negative 2 plus, this will be 3x, and then 3 times 4 is 12, equals 8x. Next step is to combine those numbers there. Negative 2 plus 12 is a 10. So this is now 3x plus 10 equals 8x. The next step is to get all our x's on one side of the equation, and probably the easiest way to go about doing this on this equation would be to subtract 3x from both sides, like that. That'll give me 10 equals 5x. And last step then would be to divide both sides by 5. And that gives me x equals 2. I could turn that around if need be. 2 equals x, x equals 2, same thing. Our solution is 2. Here's another. 2 times y minus 5 plus 3y equals y plus 6. Okay, once again, we will first get rid of those parentheses by distributing this 2 like that. That'll give us 2y minus 10 there, plus 3y equals y plus 6. Now I combine my like terms. Here I've got a 2y and a 3y. 2y plus 3y is 5y. So this is now 5y minus 10 equals y plus 6. Now I need all my y's on one side of the equation. There, this is actually a 1y. So I'm going to subtract 1y from both sides like that. 5y minus 1y is a 4y. Minus 10 equals, these y's are gone now, that equals 6. All right. Next step, add 10 to both sides. That will then give me 4y over here equals 16. And then finally, we're going to divide both sides by 4, like that. And we get y equals 4 as our solution. Oops, let me fix that. Four is our solution. Okay, let's look at one that has some more parentheses in it. 6 minus, in parentheses, 4 plus m equals 8m minus 2 times 3m plus 5. First thing I'm going to do is get rid of all those parentheses by distributing. Now right here, this minus sign is actually, think of that as negative 1. I'm going to take this negative 1 and I'm going to distribute it in. And then also on the other side, I'm going to take that negative 2, do the same thing. Whenever you're distributing, that negative sign has to go along with it, with the number. 6, this will now be negative 4, minus 1m. On the right side, we have 8m. Negative 2 times 3m is a negative 6m. And then minus negative 2 times 5 is a negative 10. Okay, so I've distributed everything. Now I'm going to combine my like terms. Over here, I can combine the 6 and the 4. 6 minus 4 is 2. That's 2 minus 1m. On the right side, I've got 8m minus 6m, which is 2m, and minus 10 there. Next step, you want all of your variables on one side, so I'm going to subtract 2m from both sides, like that. That'll be 2 minus now 3m equals negative 10. What's our next step here? Next step is subtract 2 from both sides. Negative 3m will equal negative 12. And now finally dividing both sides by negative 3. We end up with m equals, what will that be, a positive 4. So our solution is 4. Here it is. One more like this. Negative bracket negative 6x minus 4x plus 8. 9 plus 6x plus 3. There we go. Okay. First thing, we got parentheses inside the bracket, so let's distribute this negative 1 here in like that. That's going to be our first step. Let's rewrite this now. Negative 6x, this will be a negative 4x minus an 8 inside the brackets now. On the right side, at the same time here, I could combine my like terms. The 9 and the 3 is 12. This is 12 plus 6x. Next, inside the brackets, I also have like terms right there. Negative 6x minus 4x is negative 10x. Negative 10x minus 8, that equals 12 plus 6x. Next step, brackets are just like large parentheses, and so I have this negative 1 on the outside here. I have to distribute that in. It's going to multiply to that and to that. Negative 1 times that negative 10x is a positive 10x. Negative 1 times the negative 8 is a positive 8. And on the right side, we got 12 plus 6x. All right, next, we need to get all of our variables on one side of the equation. I will subtract 6x from both sides. That gives me 4x plus 8 equals 12. And now we subtract 8 from both sides. 4x will equal 4. And finally, divide both sides by 4. And I'll put it right up here. X will equal 1. So our solution is 1. Okay, now for some equations that have fractions in them. Let's take, for example, this one. 8x over 3 minus 2x over 4 equals negative 13. So this is a, fix that. Some examples on eliminating fractions. To solve this equation for x, I'm going to get rid of all the fractions in my first step. And the way we do that is we multiply both sides of the equation by the common denominator. And the common denominator for 3 and 4 would be 12. So I'm going to multiply both sides of the equation by the common denominator, or least common denominator, I should say. Both sides. Remember, you can do whatever you want to one side of an equation as long as you do it to the other side, basically. I'm going to multiply both sides by 12. Distribute that 12 in there. And that's, let's see, let's write that out. That's going to be 12 times 8x over 3, the multiplication there, minus 12 times 2x over 4 equals negative 13 times 12. How much is that? It's 144 plus another 12 is a 156, I think. Negative 156. Okay. Now, we have to multiply this fraction here. You could put 1s under these 12s if you want. 3 goes into 12 4 times. 4 times 8. This is going to be 32x minus, over here we've got 4, which goes into 12 3 times. 3 times 2x is 6x. So we got 32x minus 6x equals negative 56. You could use a calculator to help you multiply those 12s to those fractions if you need to. Okay, notice that by multiplying both sides by 12, it eliminates all the fractions in the equation, which makes the equation look a lot easier to solve. Let's fix this. Now the next step is to combine my like terms. I got 32x minus 6x, which is that 26x, equals negative 156. And now finally, divide both sides by 26. And we divide negative 156 divided by 26. According to my notes, that's should be a positive or a negative 6. Negative 6. Let me double check that. 26 times 6. Yep, that's right. So our solution is a negative 6. Here's another one where we have to eliminate fractions. (3x plus 2 over 7 minus x plus 4 over 5 equals 2. Our denominators are 7 and 5, so the least common denominator would be 35. So as my first step to eliminate all the fractions, I'm going to multiply this side by 35 and this side by 35. Get it distributed in. So it would be 35 times 3x plus 2 over 7 minus 35 times x plus 4 over 5. And on the right side we have 70. Okay. 7 goes into 35 5 times. So this is now 5 times 3x plus 2. Over here, 5 goes into 35 7 times. This is now minus 7 times x plus 4 equals 70. Okay, all the fractions are gone. I'm now going to distribute like that. 15x plus 10. Make sure that you take the negative sign here with the 7. Negative 7x, and this will be minus 28 equals 70. Combine your like terms now. 15x minus 7x is 8x. 10 minus 28 is negative 18. Oops, wrong color. Minus 18 equals 70. Next step, add 18 to both sides. 8x equals 88. Last step, divide both sides by 8. Solution, x equals 11. And so our solution there in our solution set is 11. Let's do one more here where we have to eliminate the fractions. One-fifth x minus 2 equals 2/3 x minus 2/5 x. We have 5s and 3s in the denominator, and so the common denominator would be a 15. I'm going to multiply this side of the equation by 15 and this side of the equation by 15. Distributing the 15s in now. 15 times 1/5 x minus 2 times 15 equals 15 times 2/3 x minus 2/5 x times 15. So I got the 15 multiplied there, 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 and there to everything. Excuse me. Okay, now simplifying. 15 times 1/5 x is going to be 3x minus 30. Over here, 15 times 2/3 is a 10x and minus 6x. All the fractions are gone. Now we combine our like terms. On the right side, 10x minus 6x is 4x. Now I'm going to move all my x's to the right side. So that means subtract 3x. Negative 30 equals 1x. And, well, that's solve for x, I guess. X is negative 30. There's our solution. Negative 30. Okay. A couple more things here. Eliminating decimals. Consider this equation. 0.06x plus 0.09, 15 minus x equals 0.07 times 15. Okay, we got decimals everywhere. it is convenient to eliminate all the decimals first before you solve the equation. You could solve the equation with the decimals, but it would be a little bit tougher. I noticed that the decimals that I have here, that one and that one and that one, they all go to the hundredths place. And so to eliminate the decimals, I can multiply everything by 100, like this. Times 100, so times 100. This will eliminate all the decimals. 100 times 0.06x is just 6x. And the short way of doing that is when you multiply something by 100, you just take the decimal place and you're moving over 2 places, like that. Same thing over here with the 0.09, move it over 2 places, that's a 9. So 100 times this, 0.09, is actually 9 now, 15 minus x. And on the right side, we've got the 100 times the 0.07, that's just a 7 times 15. No more decimals, the problem looks a lot easier to solve. Next step, I'm going to distribute the 9. 6x plus 15 times 9. What is that? 15 times 9, 5, carry the 9, 10, 135? 135 minus 9x. And 7 times 15, let's see here. Yeah, 7 times 15, 5, carry the 3, 105. 105. Combine your like terms. 6x minus 9x. That's going to be negative 3x. What's our next step? Subtract 135 from both sides. Let me fix that. What's that give us? Negative 3x equals negative 30. Last step, divide by negative 3. And we end up with positive 10. So there's our solution, positive 10. Let's do one more with the decimals. .10 x minus 6 plus 0.05 x equals 0.06 times 50. So just like the previous equation that I solved, I'm going to multiply everything by 100 to get rid of the decimals. Times 100 times 100. 100 times this 0.1. What is that? 100 times 0.1 is actually 10. X minus 6. 100 times 0.05? 5x. Wrong color there. There we go. And on the right side, we've got 100 times 0.06, which actually is just a 6. 6 times 50. Okay, all the decimals are gone. I'm now going to distribute the 10 here. 10x minus 60 plus 5x. On the right side, 60 times, or 6 times 50 is 300. 300. Combine our like terms. 10x plus 5x. 15x minus 60 equals 300. Add 60 to both sides. 15x equals 360. And finally, divide both sides by 15. And we end up with x equals 360 divided by 15. Let's go over here and figure that out. So it goes in twice. And that's 1, 2, 3, 24. I believe that's a 24 there. My solution is 24. Okay, just something else here real quick before this lesson is over. And that is an equation of this sort. If I attempt to solve this equation, I distribute the 5 on the right side. I get 5x minus 15 equals 5x minus 15. And so if I continue to try to solve for x, what happens is, adding 15 to both sides, or actually, let me back up here. I should actually, if I follow my rules, I am supposed to subtract 5x from both sides first. And I end up with negative 15 equals negative 15. All the variables cancel away completely. There's no more variables left to solve for. Well, negative 15 equals negative 15 is obviously a true statement. It is true. And when this happens, what that means is this equation is what is called an identity. This equation is an identity. And it means that its solution set is all real numbers. Everything works. It doesn't matter what number you put into the equation for x, it's going to make the equation true. Everything works. So identities have as their solution set all real numbers. Equations that are identities, their solution sets are all real numbers. Now compare that to this. 5x minus 15 equals 5 times x minus 4. Once again, I'll distribute the 5. We get that. I then subtract 5x from both sides, and I end up with negative 15 equals negative 20. All the variables canceled again, but now we have an equation which is obviously not true. Negative 15 is not equal to negative 20. Not true. When all the variables cancel away and you get an equation which is not true, then what we have here, this equation, is what is called a contradiction. Contradiction. Equations that are contradictions have no solutions at all. There is no solution to the equation. And so in our solution set, it would be empty like this. And if you recall from a previous lesson, we have a symbol for the empty set. It is 0 with the line through it like that. Okay, so this equation is a contradiction. It has no solution. So we write this symbol there for it. One more. Okay, now if I solve this equation for x, I distribute the 4. I get 4x minus 12 on the right side. I then subtract 4x from both sides. Gives me 1x minus 9 equals negative 12. Add 9 to both sides, and I have it solved. X equals negative 3. Okay, this equation has a solution. It's negative 3. An equation which has a solution, which is most of the equations we've solved today. This equation is what is called a conditional. This is called a conditional. Equations which have solutions are conditionals, meaning that they are true given the right condition, and that is, condition is x has to be negative 3. Its solution is negative 3. Excuse me. Okay, so once again, all equations that have a solution are called conditionals. Equations which have no solution at all are called contradictions, and solutions which, or equations which have infinitely many solutions, all real numbers or solutions, are called identities. And that is our lesson on solving linear equations.